All right, this is my favorite section we've done all year, so I'm excited to review it. It's our systems of equations. Okay, so system, first off, a system just means like multiple equations using the same variables, so with the same variables or letters. So it's kind of like just having multiple rules that you have to follow. Like each one of these is a rule. Like this first one, 2x plus 3y equals 11. It's a rule for like pairs of numbers x and y. So like I'm going to try to think of this off in my head. 4. If x is 4, that's 2 times 4 is 8. And then, okay, y could be 1. So that would be 2 times 4 is 8 plus 3 times 1 is 11. So this is a point that like passes the rule that 2 times the x number, 4, plus 3 times the y number has to be 11. So this is one point that passes the rule. Can I think of another? I'm not sure. Let's see. Maybe I could think of another. So 4-1 works. Oh no. I don't want to erase that part of the block. Let's see if I can think of another one that works. 4-1 works. How about 1, 3? Does that work? Let's see. So 2 times 1 is 2, plus 3 times 3 is 9. So this would be 2 plus 9, which is 11. So 1, 3 also works. So these are points that like satisfy just this rule. But when we have a system of equations, we are trying to satisfy like both of these rules. So we'd have to find an x number and a y number that pass this 2x plus 3y equals 11 rule, and that pass the 4x minus y equals 20 rule. And that's a much harder job than finding a point that follows just one rule, finding one that does both. And I just made this system up, so I don't even think it would be very nice, so I'm not even going to try right now. But so solutions to system of equations look like this. They're an x number and a y number. And they have to make both of them true. So it's like an x and a y number. That's what solutions look like, is a point, x, y. Okay, so we have 3 different ways of solving. The first one is solving by graphing. And to solve by graph, first we have to make sure both of the equations are in y equals mx plus b, both of them. Then we have to graph both of them. Graph both lines. Then we have to look for where they cross. So, and we call that the point of intersection. That will be the answer. X, y. Okay, so let's do this one. So y equals 1/2 x minus 4. It's already in y equals mx plus b, so let's just graph it. We have a minus 4, meaning we have a point right here, minus 4. And then we have a slope of 1/2. So that's rise 1, run 2. Rise 1, run 2. Okay, so here's our first line. It's like this, just like that. Okay, I'm going to get a different color, more different than that. How about this blue color? Okay. This one's already in y equals mx plus b also, so we have a y-intercept of plus 4, so we have y-intercept up here. And then our slope is negative 3 over 2, so I'm gonna say, instead, I'm gonna write that as negative 3 over 2, like that. So that means my rise is negative 3, meaning I have to go down 3, 1, 2, 3, over 2. Okay, down 3, 1, 2, 3, over 2. Okay, so here's our blue line, if we draw this in. Just like this. That. Okay, so now we just look for the point of intersection. So our point of intersection is right here where they cross, that point right there. And the coordinates for that point, that is 4, side to side, and then down 2. So that is the point 4, negative 2. So that's our answer, 4, negative 2. Nice. So that is a point that if we were to put x is 4 in both of these and y is negative 2, it would like make both of them work. It passes both rules. Okay, let's try another one. Here we go. So y equals 1/4 x minus 4. It's already in y equals mx plus b. Okay, so we have minus 4 is the y-intercept. And then we have a slope of 1/4, so that's rise 1, run 4. 1, 2, 3, 4. Okay. So there's my line. Second one, y equals negative x plus 1. So the y-intercept is plus 1. And then we have a slope. It's just a negative sign in front of x. That means negative 1 over 1. So that means we're going to rise negative 1. That means go down 1, run 1. Okay. down 1, over 1. So it looks just like this. Pretty good. And then we're looking for the point of intersection. So this point right here. So this is, oh man, that's close to the last one. This is over 4, down 3. So that's the point 4, negative 3. Nice. They do not always have to have a 4 and then a negative number. It was just a coincidence. Looks pretty though. Okay, so that is solving by graphing. The next thing we can do is we can solve by substitution. So to solve by substitution, we want to first make sure one variable is by itself. I think all the ones I assigned you already have that done. So one variable by itself. Isolated is the word we could use. One variable isolated. Not if we spell it wrong though. Isolated. 2, we're going to like plug that into other equation and solve. And we'll have to plug back in one more time. One more time. Let's see an example of that because those instructions might not have been super clear. Okay, so solve each system by substitution. We're looking for one variable that's by itself already. Like we have y by itself. So we know that y is actually equal to 6x plus 3. Well, look, I have a y right here in my top equation. So that means this y, I could actually just write 6x plus 3 right where that y is, and it would be the same thing. So that's what we're going to do. We're going to copy down this first equation. So like 4x plus 4, pause. Instead of writing y, I'm going to write 6x plus 3. I put parentheses around it because this 4 times that y, it means I have to do 4 times like this entire thing. Okay, and then I'll keep going. Equals negative 16. So see how I rewrote this entire top equation, but replaced the y with the 6x plus 3. And now we just got to solve this guy. So we have 4x, whoa. We have 4x plus, okay, we got to distribute. So 4 times 6x is 24x's. 4 times positive 3 is plus 12. Equals negative 16. Okay, let's see what we can hook together. I have 4x plus 24x. That's kind of hard to see. I'm going to fix that. 4x plus 24x, well, that is a total of 28x's. I still have plus 12 equals negative 16. Okay, trying to get x by itself, so subtract 12. We have almost there, 28x equals, okay, negative 16 minus 12 is negative 28. So I'm going to rewrite this over here, so we're going to keep going. 28x equals negative 28. Okay, we're trying to get x by itself, so now we have to divide, because it's being multiplied by 28, we divide by 28. So I have x equals, okay, 28 divided by 28 is really just 1. 1, and there's 1 negative, so x equals negative 1. Okay, so we just got x equals negative 1. Our answer is going to look like this, xy. We just got x equals negative 1. Now I have to get the y number. Okay, so to get the y number, I'm going to use this equation. Because I know what y is in terms of x. So y is going to be 6 times the x number. Well, we already found out the x number is negative 1, so put negative 1 in where x is, and then plus 3. So we get y equals, that's negative 6 plus 3. That is negative 3. Negative 3. So our final answer is, whoa, not the laser pointer thing again. Final answer is negative 1, negative 3 for number 3. All right, let's do one more of those so we can see it. Here we go. Okay, we already have y by itself. We know that y is equal to negative 2x plus 14. So, well, look, there's a y right here. So I'm going to put that in. I'm going to copy down the first equation, negative 8x plus 4. Oh, but instead of y, I'm going to plug in negative 2x plus 14. And then I'll keep writing, equals negative 8. Okay, here we go. Negative 8x plus, okay, positive 4 times negative 2x. Uh-oh. Oops. Okay, try again. Positive 4 times negative 2x is negative 8x. Okay, positive 4 times positive 14. Oh, that's harder. That is plus 40, I think 56 equals negative 8. We should check that. 4 times 14. Let's see what we got here. 4 times 14 Ooh, look at this cool one. I got this. It looks like the regular calculus. 4 times 14. Enter. 56. Okay, we were right. Let's go back. Okay, so 56. Okay, negative 8x minus 8x, that is a total of negative 16 x's, plus 56 equals negative 8. And we got to subtract 56, subtract 56. Okay, so I have negative 16x. Okay, it's gone. Negative 8 minus 56 is going to be negative 64. And then we have to divide by negative 16. Divide by negative 16. We get x equals positive 4. Okay, so our answer looks like xy. We just solved for x first, so we just know that x is 4. Okay, we just need to get y. Well, we know this, so let's see what we can do with that. Bring this over here. Y equals negative 2 times the x number. Well, the x number is 4. We just figured that out. Plus 14. So we get negative 8 plus 14. Y equals 6. So our final answer is 4, 6. Okay, you might want to slow those down and watch those one more time, but we did it. Good job. Okay, we can also solve with elimination. So elimination is when we we have to get opposite pairs. I was writing those as numbers. Make possibly opposite pairs of numbers. So if we had in the first equation a positive 2x and then in the second one a minus 2x, that would be an opposite pair. And then we're going to add the two equations together. And then we'll be able to solve. So here we go. Let's try this one. Look, we already have minus 8x and positive 8x. So there's our opposite pair. So we are ready to add. We are going to add these two equations all the way together. So minus 8x plus 8x, well, that's 0 x's. I don't even need to write that. 0 x's. Okay, but let's see. Positive 5y plus negative 2y, well, that's 5y's minus 2y's. So that's just 3y's equals 3 plus 18 is 21. Okay, here we go. So divide by 3, and we just get y equals 7. Cool. So our answer is going to be another xy thing. Well, we just found y first. It was 7. Now I need to get x. So in order to get x, we're going to have to go back to one of our equations. I like to just take the first one every time, because why not? So I have negative 8x plus 5. Well, wait, I know what y is. Y is 7. So I'm going to plug 7 in here. Equals 3. Okay, so we have minus 8x plus 35 equals 3. Subtract the 35, so I have minus 8x. Okay, subtract 35 means we get minus 32. Divide by negative 8. And we end up with x equals positive 4. So our final answer is 4, 7. Okay. One more of these, looking for a pair or opposite pairs, and we have it. We have plus 5y and minus 5y. So we are ready to add. Here we go. We're going to add the two equations together. Okay, 3x plus negative 4x. That's just 3x's minus 4x's. Well, that's taking away more than I have, so that leaves me with minus 1x. Plus 5y minus 5y, that's 0 y's. I don't even need to write that. Equals negative 28 plus 24 is negative 4. So we just have negative x equals negative 4. Okay, if negative x equals negative 4, that means that positive x equals positive 4. So x equals 4. So we already have the x coordinate of our answer. Now we just need the y. So I'm going to take the first equation, 3x. Oh wait, I know what x is, right? So I don't want to write x, I want to write 4. Okay, plus 5y equals negative 28. Okay, here we go. 3 times 4 is 12, plus 5y equals negative 28. Okay, trying to get y by itself now, trying to figure out y. So we have to start furthest away from that, this 12, okay? So we have to do a minus 12, minus 12. Okay, now I just left with 5y equals negative 28 minus 12 is negative 40, divided by 5, divided by 5, y equals negative 8. Negative 8. So our final answer is 4, -8. Bam. Love it. Okay, one last thing that can happen, okay? It's possible to get either no solution or infinite solutions. If we're thinking about the graph of like the lines, no solution would happen if the lines are parallel and they don't touch, right? Because they don't cross anywhere. Don't cross. The lights just turned out because I haven't moved in a while. They don't cross, so there's no solution. Infinite solutions happen when you're actually trying to solve the same like line. Like you have parallel lines, but they're actually the exact same lines. They're right on top of each other, and they cross or like touch everywhere. And then every single point down that line is a solution. Like that point is a solution, and that point is a solution, and that point is a solution. So you end up with infinite because there are infinite points on that line. So let's look at what one of those looks like. I like elimination, so I'm going to use elimination on this. And I see that we have like a positive 3x and negative 3x. So we're ready to add. Add. Okay. So 3x plus negative 3x, that's 0 x's. Oh wait, plus 9y minus 9y, that's 0 y's also. Okay, negative 22 plus 21 is negative 1. So over here I have 0 x's and 0 y's. That's just nothing. And I'm saying that's equal to negative 1? Well, that's not true. So if something like that happens and ends up being not true, that means no solution. These are actually parallel lines that never touch. If we had gotten down to the bottom and we got like 0 equals 0, if you end up with 0 equals 0, then that is infinite solutions because that is true. Okay, that's our solving systems of equation, my favorite one. Look how pretty that looks. That looks so good. It kind of looks like Easter. Okay.